Hello everybody and welcome to this new video of designing an America's Cup boat. In this second chapter we're gonna continue talking about foil sections, and we're gonna make something that is really usual in the America's Cup world, is to spy. And actually we're gonna spy the best. We're gonna spy the 3 times in a row champions of the America's Cup, which is the Team New Zealand team. So we found in a website the sections of the several sections that have been designed by Team New Zealand. These guys are so good that they share the design of their sections. Normally any section designer is pretty jealous about their section design, and Team New Zealand is they're so good that they're open to share their geometries. So I'm gonna share here down the link of where these sections are, and actually there's some sections that have been exposed in one of the Mets. I don't really know what year it was, and some pictures have been published by Boy Griffioen. So thank you so much, Boy Griffioen, to share all this knowledge with us, and thank you Team New Zealand to share this knowledge with us. And we have 4 different sections. We have one section of the AC75 or the 36th America's Cup, which is the one that we're going to use for this video. We have the hydrogen boat foil section, which is a regular hinge section as we see. And we know that this boat has been going pretty fast, up to 50 knots. So this is a real good section in terms of cavitation properties. We have the AC50, so the catamarans boats of Bermudas, which are very similar to the SailGP current boat. We don't really know where it's located in the foil, so it's a pretty big section, so must sustain a lot of load. And this is the AC40, so the one design boat foil that has been used for the previous competition of the America's Cup, of the AC37th America's Cup. So we're going to concentrate in this section. So first of all, we need to know the sailing conditions in which this section has been used, and to do so we're just going to have a quick look at the rule. So we know the boat has to weigh 8 tons with the crew, more or less. So basically the foil has to sustain all this load, and a little bit of the side force of the sail. So we're going to consider 8.5 tons on the foil, 8.5 tons, 9 tons, and the next data that we'll need will be the surface of the foil. To have an idea on the surface of the foil, we're going to take the data from this super nice video from Mozzie, which is not Mozzie anymore, which is The Foil. So thank you so much, Mozzie, for all the videos that you've shared with all of us and all the knowledge that you've shared with all of us. And in this video, that also I'm going to share here down in the description, we have all the foils of the AC36 America's Cup. Looking at the date of the what is written here, 2020, we expect is going to be the second generation of foils of Team New Zealand. There were 3 generations of foil in this America's Cup, and the first set of foils were huge of Team New Zealand, and then they removed a lot of area, and they had a really small foils, actually the smallest foils of all the fleet, and they more or less, we never know the exact numbers, but they were much more similar to the second set of foil, the racing foils that they had. So I guess this will be the section, looking at the dates, 2020, this will be the date of the second, the generation of foils. So we're gonna take, again as a reference, the same area that here Mozzie is sharing with us of 1.23 square meters. So with all this information that we have now, what we're going to do is we're going to replicate the section of Team New Zealand and try to understand their design intention. And with a bit of luck, try to improve it in some areas and understand the compromises of this improvement. Okay, so how to import this section into the TakeOff tool? It's pretty archaic. We're going to do it manually. So what we're gonna do, I've made here in Rhino a simple mirror of the section and aligning the leading edge with the trailing edge of the section. And with that, we're just gonna print the screen. We're gonna take the section and we're gonna import it in our tool. Okay, so just paste, and with the control button you will be able just to scale the section. I mean the background image that you've just pasted. And then with the little arrows you can do the fine-tuning of it. It's not super scientific, but good enough to understand the design intentions. Okay, so now what we're gonna do is modify the control points until we match the geometry. Okay, so here we go. Seems more or less well matched. And now we're gonna have a look at the flap. So that's the hinge position. We're gonna place it more or less here at the middle. Let's place it at the middle of the section because we don't really know where it's gonna be. By eye, we don't know exactly where the hinge is, but we've put it at the middle of this kind of middle piece that we guess it's going to be some kind of a flexible material to have smooth top and bottom surface of the flap. So the rule was allowing us to have 0.5, so 50% of the core being a movable part. So here we don't know exactly where the hinge was, but Team New Zealand looked to have pushed to have a big flap as possible. So now we have more or less everything defined. So let's have a look at the properties. We have 12.6 T/C, linear edge radius, trailing edge, and stuff like that. We're gonna remove the background image and we're gonna start to make some analysis on this section. Okay, so we activate the calculation section. And now let's see what kind of plots we're gonna have. We've activated alpha CL, CLCD, and CL inception speed. Okay, so let's run the polar data. I'm gonna make it slightly bigger. Up. Okay, so first of all, I've put an elevation of minus 0.5 meters. And here, the first interesting thing is what's the cavitation property that the section has. So it looks like Team New Zealand with this section has target around 43 knots of cavitation speed. So let's come back 1 second to where we were. So 43 knots, it's 0.27 with this surface. Run it again at 0.27, which would be somewhere around here. 27. Okay, so it's between 42 43 knots of cavitation. Now, just to have a reference, let's take a symmetrical section. Okay, so we're going to copy it up and down and maintain the same thickness, so 12.58. Just to have a reference section to understand where Team New Zealand tried to push. I'm gonna just shrink this a little bit more to have some kind of a good looking section. So that's the symmetrical section. So if we look at the CLCD graph, which means the lift versus the drag coefficient, Team New Zealand looked to have pushed down as much as possible around this area between 0.2 and also to have great high CL properties, which kind of makes sense as the CL range will be, I mean, around, let's say 19 knots, 1.38, and say 50 knots would be the maximum speed. So between CL 0.2 and 1.38 3, which is what we see here. So great. Another way of looking at that is putting here the envelope, which is a nice feature because it envelopes all the results, and we see comparing one section between the other. So here we see that the higher camber increases the CL, of course. If we want to see the stall properties, obviously we can reach way higher CL than a symmetrical section, and a good performance around this zone. So I'm gonna hide the reference one. What I'm gonna do, I'm gonna put this section to be able to download it here in the description of the video. So just to import it in the tool, if you want to play with it, you just have to add an entity, foil section, add, and here you just select fit from file, choose a file, and it's gonna be an ARF format. So AC36 Team New Zealand. There we go, and just click on save, and you'll have in your dashboard the Team New Zealand section, and you will be able to play with it, make some analysis, and get a better understanding of the section of this guy. So I hope you like this video. What we gonna do on next video is now use the optimizer to try to improve this section. Not only to improve, but also try constraining the inputs of the optimization, try to understand what Team New Zealand was behind designing this section. So I hope you like this video. Please feel free to download the section, play with it, give us all the feedback as you can. We will answer you with we're really happy to answer to all your questions, and stay tuned for the next video because it's going to be super cool to use the optimizer to try to beat the champions of the America's Cup and to understand better what were the design principles. So stay tuned, thank you very much, and see you in the next video. Bye.